I'm Sarah Jensen, editor of OEM Off-Highway, and welcome to Design and Engineering Insights. Today, I'll be speaking with Gabriel Roberts, Director of Product Development at Jacobs Vehicle Systems, about engine brake technologies. So thank you for joining me today.
Thank you, Sarah. Glad to be here.
So maybe could you start by providing an overview of Jacobs engine brake technology, kind of going to how it works, what benefits it offers?
Jacobs is the industry leader in providing engine brake technology. We've been in business for over 60 years, providing engine brakes. Most heavy-duty trucks on the market today have engine brakes. They all use them. They all see value in them, so they're very commonly used today. The modern engine brake is evolved since the early engine brakes. Today, the vehicle knows exactly when to use the engine brake, even if the driver doesn't know how to use it. But when a driver goes to activate the engine brake, what happens is an electronic signal is sent to the engine, and within the valve train of the engine, there's an engine braking system. I'll call it an engine braking actuator. And when the truck or driver commands the engine brake on, that actuator extends and it modifies how the valves operate within the engine. What happens is normally in a compression stroke on the engine compresses the gas in the cylinder, and then after top dead center, it returns that compressed energy to the crankshaft. In engine braking, what happens is when the compressed energy reaches TDC or top dead center, we open an exhaust valve just a little bit, and all that compressed energy goes out into the exhaust system. That creates that sound, that that you hear going down the hill. That's the compressed energy going out. So every engine's different, every technology and every OEM is different in how it does that. But basically, the fundamental technology is that. Mm-hmm. And I would say your last part of that is what are the benefits, right? What do the people see for the benefits of an engine brake? Number one is driver confidence and safety. And number two is it extends the life of your foundation brakes. You know, I've been in a truck. I've actually driven a truck down a 7% grade and found very scary with or without an engine brake. And I know if I had to use my foundation brakes or I didn't have a supplemental retarding system like an engine brake, I would lose confidence in there and be a little scared about that approach. So it definitely helps driver safety.
Have there been any recent advancements or trends within engine brake technology that you've been seeing recently?
There's always a drive for more power, right? Mm-hmm. So as engines get more modern and, you know, the air handling, the turbos, everything gets more advanced, we can always get more power out of it. Now there's a lot of actuators on the engine that we can optimize performance. So the trend has always been as much power out of an engine braking system that you can get, and that's there. But I would say one of the most interesting trends that we see now is shifting. So OEMs are starting to use the engine brake for upshifting. A lot of times, I think Freightliner probably does this the best. When a truck's going up a hill and an automated manual transmission is quite common today, when it goes to upshift, it has to separate the engine and transmission while the engine speed comes down. So now some OEMs are applying the engine brake in a split second to drive the engine RPM down to allow a quicker shifting. Quicker shifting means you have less torque split and therefore you get better fuel economy. So OEMs are adopting, it's a new trend now, is that shifting, using the engine brake for shifting is becoming more and more common, I thought.
Has there been any recent developments or advancements that Jacobs Vehicle Systems in particular has been doing or working on?
The most recent is a lot of engines are taking an advancement into emissions technologies. So there's a lot of pressure from California and in Europe and even in China to reduce heavy-duty diesel emissions. So we see the valve train getting very complex. It becomes, you now need to do, instead of just intake and exhaust and engine braking, you need to provide complex valve motions. So a lot of what we're doing is creating a modular valve train, a valve train that can do, I'll call it like a Swiss Army valve train, a valve train that can do engine braking, it can do cylinder deactivation, it can do late intake valve closing to improve fuel economy, it can do decompression for start-stop cycles. So having a valve train that's modular that can meet all of the OEM's requirements as the emissions get tighter and tighter over the next, say, 10 years to help improve emissions there. Another trend we see is in the off-highway market. There's off-highway hills, just like there's on-highway hills, right? So people that drive tractors, people that drive combines, people that drive, mining vehicles, especially mining vehicles, they need retarding, just like they see the same values as on highway. They see saving the brake pads. They see going downhill safely. That's all something they need. So we see a significant growth in engine brakes for use in off-highway. And I would say that the third trend or third thing that we're seeing evolve that we're working on is thermal management, using the engine brake to keep the engine hot or get the engine hot. You start up the truck in the morning and it's cold out. You can turn on the engine brake on some cylinders. You can turn on fueling on the other cylinders, and it gets the engine hotter quicker. And the same thing, if you want to do a regen, a DPF regeneration, active or passive, depending upon how the OEM is programming the engine brake, they can do or use the engine brake for regeneration. So thermal management is a unique trend we're seeing.
How can the engine brakes possibly help to extend the life of service brakes in heavy duty on and off highway equipment?
When we design an engine brake for an OEM, it needs to hold the vehicle constant speed when going down a hill of approximately 7% grade. So and I would estimate that probably takes a negative 500 horsepower to do that, to hold the truck back at 80,000 pounds. So that's what our kind of design target is to do. Now imagine you're going down the hill without that, right? And you're just using your foundation brakes, and you're on the pedal, you're on the brake pedal, and the linings are wearing and the pads are wearing, and they get very hot, and you get very hot brakes, and that exponentially increases the wear on your foundation brakes. So by the end of the hill, your brakes are hot, maybe they're smoking. You had a little bit of a scary trip if you're coming out Eisenhower Tunnel or one of the big hills there. So you just went through a significant portion of the life of your brake pads. Now, put on the engine brake, that whole trip down, you're just using the engine brake. It's unlimited use, right? It never tires out, it never gives up, it never fades. It's there for as long as you want it. You just save that amount of wear on your foundation brakes. We like to say that a standard engine brake can multiply the life of your foundation brakes by 2 to 3 times. So a truck that doesn't have it versus a truck that does have it, your total cost of operating that vehicle is much lower because you don't have to replace the foundation brakes as much. Mm-hmm. And some of the new technologies we have rolling out, it can get up to 5 times the interval of a non-engine brake equipped truck. Mm-hmm. So it definitely makes sense to have one.
How does the company maybe foresee engine brake technology advancing in coming years? Are there any specific technologies or trends regarding engine brakes that you guys kind of see coming, or is maybe electrification and hybridization, since that's kind of increasing, is that having any sort of impact on engine brake designs as well?
It hasn't really emerged as a production path, the hybridization or electrification yet, so we haven't really focused much on that. I would say short term, one of the more interesting trends is how the engine brake is used for cruise control. Mm-hmm. So many times, just like in a car, the cruise control is used to modulate the speed for acceleration, but also deceleration. Mm-hmm. So now truck OEMs have become smart in that area, and they use the engine brake for retarding the vehicle automatically in cruise control too. So when you're going down a hill, as you crest the hill, the truck will sense that it's in a downhill mode and the speed starts to exceed its set point. It can then modulate on an infinite scale the amount of engine braking power that's given to the truck to keep a constant speed. If you're only on a mild grade, maybe it can vary. Maybe you're only getting 100 to 200 horsepower of the engine brake. But if you're on a steep grade, it's going to give you all the power. So that automatic control and modulation of the engine brake performance is a pretty neat trend that we see out there going on. I mentioned the shifting, upshifting, but a lot of OEMs also use the engine brake for downshifting with an automated manual transmission. They can downshift the transmission to keep the engine brake operating in the high RPM phase and the high RPM range to give you the most power. You want to get the most power, you want to be 1600 to 1900 RPM, so they can shift the engine brake automatically to be able to drive. So now drivers are using the engine brake in start-stop traffic. They're at a stoplight, they're coming to a stoplight. The engine brake will become active all the way down to 5 or 10 miles per hour before it shuts off. And that helps the driver, helps in control, and helps save the foundation brakes too. I think those are the most prevalent trends we've seen and the things that we're working on now.
Well, thank you so much for taking the time to speak with me today and provide some insight on your technology and how you see it progressing in the coming years.
Sure. No problem. Thank you very much. I appreciate it.